Stanford University.
Let's do a quick round of introductions.
All right, I guess I'll start. I'm Ewan Ashley. I'm a cardiologist in the School of Medicine. I have the honor and privilege of leading the Biomedical Data Science Initiative. I usually say I was born a geek, but trained as a cardiologist. I did medical school in Scotland. You could probably tell from my accent. I did some statistics during a PhD in Oxford and moved to Stanford about 12 years ago. And so from when I first visited, this was clearly the place I wanted to eventually call home. And the combination of bringing the sort of engineering and computer science and theoretical tools that we have developed in a place like this to the application of medicine is the thing that excites me the most. So looking forward to the discussion today.
So I'm Vijay Pandey. I'm the leader of the theory initiative at the School of Humanities and Sciences. I'm actually in a couple different departments. I'm in chemistry, but also with courtesy appointments in computer science and structural biology. I'm also director of the program in biophysics. So my research is at the intersection of a lot of different areas, but especially we use a lot of data science methods, especially for understanding fundamental biophysics and also for coming up with new small molecule therapeutics.
Okay. My name is Hector Garcia Molina. I'm in the computer science and electrical engineering departments. I was talked into being the director of the Stanford Data Science Initiative. My colleagues twisted my arm, which is it has a lot of engineering folks, but there are also other people in statistics and other departments, and we have a lot of already existing collaborations with other groups on campus. And I should point out that the executive director, the guy who really does everything, is Steve Eglash, who's sitting right here. And if I get a really hard question, I'm just going to ask Steve to answer it.
I'm John Hennessy. I'm actually a computer. I have a same appointment Hector has, EE and CS appointment. I'm a computer scientist. I came here to figure out what the difference between a data scientist and a computer scientist was, which I expect to learn today. But anyway, I have an interest in this. I think it's an important initiative, and I think it has many of the interdisciplinary roots, I think, that we've tried to hone and improve here in the university. It also, I think one of the other things that's attractive is it has deep roots on everything from theory to application, and I think that promises a lot of opportunity for the university where we have faculty across that entire spectrum.
Perfect. Okay, great. Thank you. So the first set of questions is more about understanding what data science is, just to make sure we're all on the same page. So let me ask by just asking maybe each of you to pick one application area for data science, be it healthcare, climate, whatever, one application area, and explain kind of how data science is going to revolutionize that field. And we can take it in turn.
All right. Okay, I'll go first. So one of the things that I have been focused on in my own group over the last few years is a tremendous technological advance, which is the change in the cost of sequencing human genome. You may be aware that it cost $3 billion to fund the Human Genome Project about a decade ago, and that over the course of the last 10 years, that cost has dropped down to $1,000. So a million-fold drop in the cost of sequencing a genome. And that has had already an absolutely transformative role to play in changing medicine. To give you an example of that, we had a little baby admitted to the neonatal intensive care unit at the Children's Hospital a few months ago who had not a mystery syndrome, but something we understood well, long QT syndrome. This was associated with cardiac arrest, and the little baby had multiple cardiac arrests on day 1 of life. We know the genetic basis of that condition, but at the moment, with the standard approach, a genetic test would take 3 months. It would look at 5 genes, so very small data, and it would give an answer that would help the physicians then do what we're increasingly calling precision medicine. We'll probably come to that phrase later. With the new technology, we can do a whole genome sequence which produces 6 billion data points in 24 hours, analyze it using algorithms that used to take days that now take hours, and put the result back into the hands of the treating physicians in days. So if I was to think of one example that could encapsulate what we can do and what data science could bring to medicine. We've looked at one gene at a time. We've looked at, you go in and you have a lab sample and maybe 10 reagents come back to you. But now we have technology that can deliver 6 billion results back to you. And there's a huge signal to noise issue there. And so the sorts of things that colleagues in engineering have been dealing with for many years suddenly become extremely relevant to things that are happening in the medical school.
Yeah. Okay.
Yeah, so I think the example I would give is also in the healthcare area, but from a different perspective. What I think a lot about is how we design small molecule drugs. And Right now the procedure is very empirical. If you think about it, when we do other things, like we design a bridge, like the Bay Bridge, we don't do that the way we design drugs. If we did it that way, we would have some idea for the bridge, we'd think it works, and then we'd first send mice over the bridge to see if they survive. And then, and then if the mice survive, we would take people who really want to go to San Francisco and we'd put them over the bridge first. So we would never do that, right? And so it's interesting, I think, why can't we engineer small molecules in an analogous way? And there's many different answers to this. This is an extremely difficult problem. But I think the opportunity now is that we have a huge data sets, and so huge that you can't have a single person wrap their head around them. And I think the promise of data science is that we'll be able to algorithmically gain insights, and insights that are really non-obvious.
Hector.
Okay, well, just to be contrarian, I'm going to mention old applications like finance, commerce, manufacturing, where they're not as trendy, but they're still very important, and there's a lot of great things that can happen to produce products and services cheaper, more efficiently, and safer. Again, because we have a lot more data about the process of manufacturing or about the customers and their needs and their desires. So it's a combination of more data and better ways to do things.
So more data and better algorithms.
And better algorithms.
Yeah.
And better services that we can provide.
Yeah, makes sense.
So I think one thing that is going to be possible now is the work that's going on deep learning. And really, the funny thing about deep learning is deep learning will give computers what we would call common sense. It's really the ability to devise relationship. And that's happening now because we've learned enough about machine learning and we have enough data. You want to learn about the world? Go read the internet. Read the internet. Put down all the relationships you get about the internet, and then build a system that can reason about them. So you need both large amounts of data and large amounts of compute. And we're going to spend a lot of money doing things which people could do easily right now for smaller amounts of money. But in 10 years, they'll be a lot cheaper, and that will be liberating.
For me, for my area, the application of data science that's really exciting is the application actually to computer security. So as you might realize, attackers are constantly doing new things. And for us, it's not new data. It's not large amounts of data and new algorithms. It's actually the fact that there's new types of data that are being collected in order to detect attacks. Just as examples, LinkedIn, for example, is constantly being bombarded with fake accounts, right? So how do you detect fake accounts in the massive sea of accounts that they have? That's all based on data science techniques. But is this really a new field, or is it just like John says, is this just more computer science and more statistics? Is there something fundamentally new happening here? Are there kind of new techniques that are being developed, new ideas that are being developed, or is it just is just a new name to an old concept? Yeah, please, Hector.
Can I take a crack at that? Definitely, data science is new in the same sense that Columbus discovered a new continent 500 years ago. Where there happened to be a lot of people living there already. So it's sort of similar. There's a lot of data-related work that's been going on for the past years. But what's really new is the discovery that a group of influential people have discovered that there's a lot of value and power in data and mining it and analyzing it. And that's what's exciting. Now, I'm not implying that everything has been done, right? Even after Columbus discovered America, there were still a lot of good things that happened in America.
There was South America.
Excuse me?
There was South America, for example.
Well, I meant America in the broad sense.
America.
The Americas.
Now, Hector, I want to point out that Columbus's discovery did not go so well for the people who were natives to that country. I hope you're not going to do the same thing in data science.
Why not? Why not?
Yeah, it's a good question. I think this is a good question because Jeff Ullman, my colleague in computer science, once said, anything that has to call itself a science ain't one. And I think there's some truth to that. The question will be, take computer science as a discipline, right? Over time, yeah, surely its foundations are in lots of other disciplines, but over time there became a core body of knowledge that distinguished what computer scientists know, right? And it's about algorithms and complexity and computability and autonoma, and there's a core body of knowledge. My guess is the same thing will happen here. There'll be a core body of knowledge. It will build on statistics and mathematics and other disciplines, computer science, but it will be increasingly distinct as our applications frontier moves forward over time.
Yeah. Also, a lot of times we define, these disciplines by the curriculum that we teach.
Yeah.
Because, you can be in a computer science department or a biology department or a math department and do whatever research. But often it's the discipline that we want to teach the younger generation, which is a key aspect of it.
I think the absolute scale is also larger. I mean, I think there's no debating that compared to 10 years ago, the amount of data in the world, the amount of data that is being passed through the pipes on an hourly basis is greater. And so that can lead to, I think, learning that wasn't possible with smaller data. But I think it can lead to opportunity in extending current disciplines. So it's certainly not replacing anything, I think, as John said. It really builds on those, brings them together. And I think for me, it's almost like I don't really care at some level whether it's new or not. What is clearly new is the availability of data and the problem as to what we're going to do with it.
What are the techniques that make the field its own unique, distinctive field from just machine learning or just databases or things we've had in the past? Are there specific things that folks here can learn about that make them data scientists?
Yeah, sometimes it's not necessarily going to be something truly unique. In making an analogy to other things like biophysics, biophysics is a mixture of physics and biology and other areas. And it's maybe more about sort of how we do that mixture, what the cocktail is like. Because different cocktails can have similar ingredients, but different quantities of each.
I think lots of people will want to own certain techniques and will want to have them under their wing, and I think that that's okay. I think that, again, for me, it's the application that counts, rather than exactly which box we put it in. And so, for sure, I think the most common answer to your question is machine learning, deep learning, and applying that to extremely large data. That's probably the closest to the thing that's new that's sort of associated with data science. But really, isn't that just an extension of statistics? I think probably, many levels it is. I mean, I would say there's a very broad range of tools that come from multiple toolboxes, but I would...
Yeah, I think that's right.
Yeah, we're using a lot of existing tools, but the process of applying these tools to new domains, new applications will improve the tools over time.
Mm-hmm. So I think Dan's point's well taken. I'd say right now, saying you're a data scientist or you're working on data science is a way of defining a collection of disciplines and knowledge that you have from different disciplines. It's not yet distinctive in that way, and it may not be, because I think you can see statistics and computer science kind of embracing these techniques and developing them further as a natural evolution of their own disciplines.
So basically, we don't quite know yet what makes a data scientist a data scientist.
But we know when
But
we
we
see it.
intend to
We know it
discuss
when we
it.
see it.
We're going to learn.
That's part of the challenge,
data.
I guess.
Yeah.
But it does sound like if you want to become a data scientist, you need to know machine learning, you need to know statistics. Those are the general areas that you must know in order to call yourself a data scientist. Is there agreement on that?
Yeah.
Yes?
Yeah, and
Okay.
something about computation. I mean,
Always helpful. So the question is, what is the role of universities in this new world? I mean, how do we get the data that is proprietary, has privacy regulations around it? Companies are just not going to share the data with us. So how are we going to do data science in academia if we don't have the core data?
Yeah, I mean, I actually would challenge the assumption that the companies are the only ones with data. I think Ewan can speak very much to genomic data, which there's huge of, and actually we have a whole hospital there full of data. I think astronomy is very data rich. I think not all fields are data rich, but I think there's many fields just within academia that are themselves data rich.
Yeah, I mean, I think if you take the hospital for a moment, I mean, the 500 beds, many of them are telemetry beds, which mean that we have real-time signals coming from the heart rate, from the ECG tracing, electrical tracings of the heart. We have every day on probably too many patients, but we have lab tests that are coming in streams. And for the most part, that data is reviewed on a daily basis, kind of reviewed somewhat in a time series way, manually, on a screen at least, no longer on paper, and then kind of dismissed. There is no algorithm sitting in the background that understands, like your fraud alert on your credit card, what the normal boundaries for you are. And probably there should be.
But actually, they've got resources that we don't have. At Google, you could run a 10 million core job. It wouldn't be a big deal. That's impossible to do on campus.
So I agree with Dan. I think our data is a drop in the bucket. We don't need data on 500 patients or even a year's worth of 500 patients. We need data on 10 million patients or 20 million patients if you really want to start working on the problem. And that's got to be a full set of data, not only genomic data. We need lots of medical data. And I think we're going to have to find a way. And I thought the secret was going to be, I thought you were on this panel, Dan, as the one who was going to help us break into their systems and suck all their data out, you know?
I see. Data theft is a different panel. Data theft is a different
That's a whole nother department.
That's right.
But the issue is related to privacy. One of the topics
We're
near
gonna
to
get
you.
to that. Yeah.
Because I don't think it's an issue of Stanford data versus other industry data. It's an issue of people are very paranoid these days for various reasons. And even the government that has public data doesn't want to share it. So getting any type of data is hard. I mean, we've had some trouble in the past, although I'm assured that that's not no longer going to be true with our hospital. Trying to get any data out of there was hard. And there's a good reason for that. There's HIPAA and all sorts of constraints.
One of the things we learned about the NSA Snowden thing is that just collecting the metadata, in fact, gave them a fairly good look into some people's lives. So how you anonymize it while maintaining the structure of the data in such a way that you can reason from it is going to be harder, I think.
We have a lot of admissions data on campus. Can we use that for research?
I think it is the intention that we have the education data, and we're going to use that as a way to, and this is, I think, is one of the big issues about moving to more online methods, is that you can build the analytics and get more information about what students learn and have a shorter feedback loop. I think we definitely want to do that.
So the university would be willing to share education data that's being collected with the researchers in the data science initiative?
Sure. And even admissions data at some level, obviously. There's certain things you've got to keep anonymous, but at some level.
That's great. That's good to hear.
It was a fascinating data set. They wanted our help to study this data and tell them what to do, what they could do with this data. But at the end of the discussion, I asked, well, okay, so we're very interested. How do we get the data? Oh, I don't think we can give you the data.
Anyone who's here who would like to come and work on it, please come and find me afterwards, and I can point you to any number of data sets that need people to work on them. So I think absence of data is not our challenge, but there is still a role, I think, for synthetic data sets.
I could just see when you go to your doctor. I guess you are a doctor, but you must have a doctor.
Sort of tell me.
And so here, I have this pill for you. We've tested it on Tron, this simulated human. The simulation was written by an undergrad I have here at Stanford, and it works fine. Tron survived and improved. So here, take this.
And the students graduate, and we don't understand how the simulation works, but we think it's okay. I think the synthetic. I worry about models that are developed around synthetic data and the fact that you fit the algorithm to get to match the synthetic data. I worry about that. I also worry about, we've kind of moved away from this name big data, and I think one of the reasons we did is there's lots of big data out there, but lots of it isn't particularly complicated. It's simple data. It's not complex relationships. And when you think about synthetic data, how are you going to get synthetic data that has deep, complex relationships that are not artificial, but in fact look like the real thing?
I think ultimately we're all talking about the same thing. We're not going to simply put data sets together and then sit back and say, well, we feel really good now, we've got a great data set. The point of putting the data set together is to ask a question. So I suspect we don't disagree as much as maybe we sounded like we might have done.
Yeah, I think especially we led off with some examples of questions, but I think questions are very domain specific. And the part that is common is maybe more methods.
Yeah, I could give another quick example just from the idea sort of that it builds upon federated queries, but moves towards federated statistics. Because again, as we mentioned earlier, probably one hospital, if I'm going to keep away from the domain, but one unit, it may not have all the data in one place that you want to analyze, and there may be privacy, and we'll get to this, privacy or regulatory reasons that you can't actually bring that data together in one place.
There's a lot of really challenging problems in just getting data that's usable. It's not just you get some file from somebody and you're all set to go. You have to organize the data. You have to understand what does it mean when you have a field there, how an instrument was used to measure this, and how do I combine this reading in this field with another reading that's related but was done with a different instrument or measured in a different way, for instance. So there's a lot of challenges. How do I represent the accuracy in the data itself?
And generally, how do we adapt the curriculum to deal with teaching data science and data science skills?
I mean, I have one idea towards this. One of the things that I have always been really impressed about the new CS curriculum is that CS can be done in a very project-oriented way. If you think about like 106A, students can see the value of computer science very quickly because they're actually doing it. And you can imagine having data science-like projects in other disciplines where the project has to do with analyzing the data. And maybe they don't take the data themselves, and that would be very onerous and almost maybe impossible in some cases. But I can imagine that there could be applications like that. And I think my personal prediction is that education will start to look more and more project-based, as I think it has a greater impact on the students and also becomes just more exciting for them.
Yeah, we've had success in CS with some classes where the beginning of the class, the instructor has put together 20, 30 data sets, and then the students can pick one that interests them. Often they can even go and talk to the person who generated that data set, and then they can do an interesting project with it. So I think that same idea could be used in many disciplines.
So you see this as, you mean there many faculty here are teaching classes that could adapt to that model, where there would be more data sets available and the courses would actually focus on how to analyze those data sets?
Possibly. I mean, I'm not sure, since I'm not an expert, I don't know how far we can go to data mine Shakespeare or something like that, but it
can be done. There's actually a professor here in the English department who's been analyzing old manuscripts. I don't know, I think Shakespeare.
Yeah. Right.
Well, I think, and then in the medical school, I think we have a slightly different challenge in that we're generally training people not to be data scientists, we're training them to be doctors, but yet data science will be such an important part of medicine going forward that we need them to be much more quantitatively aware than they currently are. And so there's been a number of movements towards thinking about how to improve or increase the amount of exposure to those topics that our medical students have, because they're going to need to understand the theory behind it, if not necessarily have to be able to actually apply at the command line all the things that they might.
And understand what they can trust and what they can't.
Yeah.
If you think about core data scientists, as opposed to, we're going to have lots of students who learn about data science techniques in the context of whatever they're doing, biology, chemistry, engineering. But I think we also probably want to think about a core educational program that trains people who are deeper in the fundamental techniques and applying those techniques, and maybe not so focused on the applications in any single area. And that's a good model for how that might be done.
So here I have to remind everybody of this example of a father who went and complained to Target about his teenage daughter getting bombarded with ads for cribs and for diapers, only to find out that Target figured out that his teenage daughter is pregnant before she told him. So yeah, that was quite interesting.
True story.
True story, absolutely true story. So the question is, how did Target actually do this? And it turns out what they did is actually, well, they had data scientists who were actively working on their data, where they had mothers sign up for their baby registry, and then they started analyzing what do pregnant mothers, soon-to-be mothers, what do they buy? And it turns out, like in their second trimester, they tend to buy unscented lotion. And then in their first 20 weeks, they load up on supplements like calcium and magnesium. And quickly they correlated that to the fact that someone is expecting just based on their purchase patterns. So that's an example of kind of crossing the border of ethics and data. And I guess that's what you're getting at. Is there limits? Should there be limits to what data is being collected? And generally, what do we do about the ethical question?
And should we teach them the difference between correlation and causation?
There you go. There you go. Very, very important. Indeed, very important.
Right, if you have the data, you can study it, and if you discover patterns like this, as long as it's not referring to a specific teenage girl, I don't see an issue. It's the specifics of when it leaks that this specific girl is pregnant, that's when you have problems.
So then, Hector, let's put it in. So now you discover this connection, you publish it, and the next thing that happens is Target then deploys that algorithm using your discovery, or somebody else deploys it, and they start then bombarding the advertisements. Now they've used your insight to create a problem.
Yeah, but this can happen. I mean, whatever algorithm I develop, it can be used by bad guys to do bad things. So I shouldn't be doing my research.
This is a common issue in technology, from atom bombs to anything else. I mean, I think the challenge especially is that if Hector didn't do it, maybe 10 or 20 years later, someone else would do it.
Of course somebody else would do it. In the digital world, increasingly, you have to do something really contrived if you really want ultimate privacy. It's the honest. I mean, Dan's right. There's a scale issue here and a pervasiveness issue that's very different. I mean, well, look at credit card data. Everybody, does everybody use credit cards? Yes. And imagine that data being crunched not just by the credit card firm, but then sold, because of course it is sold. And used in lots of different ways to determine buying techniques and things and this is true in all the stores now. The new way to try a new product out is you pick a few stores and you go watch who buys it, and you watch information about who buys it. And they use a credit card. Now you deduce from that what kind of people might buy that product, and you decide what stores should have it and how much space it should get.
That's why when I go shopping, I wear a brown paper bag on my head.
You do. And you use cash?
I use cash.
He uses Bitcoin.
Yeah. Some kind of regulation is going to be necessary. I think trying to shut down the research side of the agenda doesn't work. I mean, it basically doesn't work. So you're going to have to figure out what companies' regulations are about security and privacy. And the problem with that is that that involves government. And government moves about 10 times slower than technology moves. So it's going to be very hard to develop that. And you just have to look at what's happened in copyright law and how far out of date it is. Not, 50 years out of date? Probably something like that, right? And so we're going to have that problem as a society. This is a societal issue. It's going to have to get to.
Okay, I guess we have to leave some topics for next time. I did want to talk about the role of libraries and can libraries help with data collection and data retention, but I guess those are things we'll have to talk about
I think
next
they'll
time.
have to is the answer.
They'll have to. They'll have to adapt, including the Stanford Library. Yes, it would be really nice if the Stanford Library.
We don't have the most old-fashioned library in the world.
Exactly.
We're ahead of that curve.
Oh yeah, absolutely.
In terms of so.
Actually, I did want to advertise. There is something called. Maybe you guys want to talk about the Stanford Digital Repository.
I think they don't think libraries about books. Libraries about data.
Okay. Well, thank you, everybody.
Okay,
thank you.
thank you.
Thanks to panelists.
Thank you.
For more, please visit us